Okay, this question is on the differentiation and the reverse. So after differentiation, we do it as an integration. So both differentiation and integration are involved. And for this question, you need to be very careful in the writing. Otherwise, you'll find that you actually don't see, you'll find the whole question very confusing. Okay, so if you look at the first part, your job is to differentiate. So you should realize that you need to apply your product rule. Okay, so I'm going to run through and then later on you try to execute it out yourself. So if you apply your product rule, okay, I assume you will know how to do your u dv dx plus v du dx. So basically, if you try, you should be able to get something like this. So if your differentiation is correct, you will get something like this. But if you try already, and then it's like, how am I supposed to prove the 8x minus 5? So you need to observe that this is the same bracket, but there is a difference in power. So do you realize that there's a difference in power? So 2/3 and 5/3. So in such a case, right, there is a take out common factor. The common factor will be the one with the lower power. So your job is to take out common factor. So how are you supposed to do the take out common factor? Okay, so let me show you first. So if you take out the common factor, this will be left with a 5x. But if you take out the common factor here, you are doing a divide. So you are dividing your common factor. So when you are doing the take out common factor, you are dividing. And this part here is your indices. You will subtract the power. So you will get power 1. And that's how you get this. So you got the 5x. And then when you divide using the indices, you get the 3x minus 5. And that's how you get your 8x minus 5. So there's this part that involves indices. So your take out common factor, you take out the one with the lower power. But when you take out the lower power, you are dividing by the lower power, and that leads you to the indices part. Okay? And then after that, right, is a hence question. After that is a hence question. I should make use of my differentiation to find this. So look carefully. You hope to find the integration of x multiplied with that bracket. Okay, can you make sure that it's actually different? So do you realize that it looks almost the same, but it's actually different because it's a power. Okay, so I'm going to show you. So make sure you realize that it's actually different first. If you didn't even realize that the power is different, then you'll be thinking, why the first part and second part looks the same? Well, the first part is differentiate and the second part is integrate. So anyway, they are not supposed to be the same. Okay, so I'm going to make use of this, the first part. So what can I make use of the first part? So I'm going to reverse back. So now that I prove my differentiation already, I'm going to reverse back. That means, right, if I integrate, I will get back the original product. So that's exactly what I'm going to do. I'm going to integrate this and I will get back the original product. The original product is the one that has power 5/3. So you integrate back. You integrate, it will return you the original product. Okay, so have this idea first. I'm going to integrate and then I'll get the original product. The original product is the one with power 5/3. So how am I supposed to break the integration until I gotten this? So you take a careful look. This bracket can be multiplied with the whole thing. So that's how I gotten this. I'm going to split the bracket. Then this minus 5 can also be multiplied with the whole bracket. So that's how I gotten this. So I split this into two terms. Okay. After I split into two terms, I'm going to split into two definite integral. No, sorry, not definite integral. Two integration. So because it's a subtraction, so don't forget, if let's say you are doing a subtraction, you can always split them up. So that's exactly what I'm going to do. So I'm going to split. So this one will become one integration and the 8 can be taken out. And this is going to be another integration. So this part is not changing. The original product is not changing. So do take note while you are focusing on the left side, the right side is not changing at all. Okay, so observe the two integration. If you observe the two integration, this is what the question wants. The question is asking you for this. So do you realize the question is asking you for this? So this is the one that the question is asking for. And whereas the second integration is something that I can integrate myself. So it's something that I can integrate myself by applying one of my basic integration formula. So bear in mind, while I'm doing the integration on the second part, the left side doesn't change. So all the yellow part here doesn't change. So you do your integration on the second part. Then you bring over the blue color part. So the blue color part is brought over to the yellow side. The blue color part, initially it was negative, then it is brought over. Okay, now take a careful look. Here is a trick. Did you see that after you bring over the blue integration, did you see that this is a common factor? Do you realize that both have the same power? Okay, so this was the original yellow. Okay, after you bring over the blue color integration, these two are the common factor. So if you take out the common factor, that's how you get the x plus 1. And the last part, divide over. That's how we get the 1/8. That's how we get the exact format that the question wants. So k is equal to 8. So this is the differentiate and hence integrate idea, but it's a bit more difficult because the power, if you don't realize the power is different, you find it very, very confusing. So if you are the kind, your handwriting is very confusing or your handwriting fly everywhere, you get yourself very confused. Okay, the next part if you can successfully do this, okay, your job is to do a definite integral. So look at this and this. So you use whatever you have to try to do a definite integral. So definite integral means you do a top minus bottom. So you can do out the top minus bottom yourself and you actually get a 0. So if you still remember what's the concept behind definite integral. So definite integral is supposed to help you to find the area under graph. But in this question, if you work out the definite integral, you actually got a 0. So they are asking you, what does that imply about the curve? So my idea will be, since the area is 0, but how can the area be 0? So from 5/3 to -1, I'm expecting the graph to look like this. I just randomly draw like this. So I expect that the negative portion and the positive portion will cancel out each other. So that's how the 0 comes about. So there's this negative area and there's this positive area. If you try to integrate, that means you never split into positive area and negative area. You do it direct. They will actually cancel out each other. So for example, the top area is positive 2 units. The bottom area is negative 2 units. So when you do a direct integration, you get a -2 plus 2. So the implication will be, because the definite integral is the integration of area under curve. And if I get a 0 in such a case, that means half the graph is above the x-axis and the other half is below the x-axis. So it's exactly half above and half below. So that if you do a direct integration, it will cancel out each other and get a 0. But in actual fact, if you have calculated them separately, you will not get a 0 area. So in actual fact, if you calculate out that this is a +3, +2, and then the negative part, you make it positive, the area will be a +4 units. So that's why in the concept of area under graph, you must calculate positive and negative areas separately, or else they will cancel out each other. So this is the logic behind the question.